Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design using MATLAB Simulink. Today is day 20. Today we are going to discuss about Simscape Fundamental for electromechanical systems. So since we are going to integrate electrical system with the mechanical system, so we are going to discuss about electromechanical systems. So I welcome you everyone here. First of all, I would like to say sorry for this late 10 minutes delay. Yeah, I welcome you everyone. Yes, Sandhya, Manisha, Ramesh, Mohammed, Himanshu, Raghavendra, DC Anil, Gautam, Porkodi. Welcome participants. Hariharan, Praveen Kumar, Raghavendra, Vanilla, Lokesh. Warm welcome. Am I audible for everyone? Am I audible for everyone? Can you please comment? Yes. Lemon, Sanjeev. Good evening. Very good evening. Yes. Mayuri, Nilesh, very good evening. Hi. Srinivas, hi. Good evening. Ganesh. Yes. Chetan, thank you, Chetan. Yeah. Srinivas, yes. Thank you. Fine. Okay. See, about the Pantech. Pantech is a educational equipment manufacturing company for EEE, ECE, computer science, IT, and IoT, AI related products. You can get it from the Pantech. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 1.5 lakh students. Yes, very good evening. So let's start the class. Already we late 15 minutes. Yes. So now we are going to discuss about Simscape component fundamental. See, actually yesterday we have discussed about some concepts like a through variable and the across the variables. So what are all the multi-domain systems? So can you please comment? Akshay, yeah, we will start the new next batch by tomorrow. Probably tomorrow we can start. We will send you the email. Mr. Anil, you please WhatsApp me after this live. I will be able to respond to you. Now you can start the class. So can you please comment what all the domains are available under the multi-domain physical systems? So can you please comment what all the domains are available? Yes, I am waiting for your comment, participants. So what all the domains are available? What all the domains are available? Mechanical, electrical, hydraulic, and thermal also. Right? So yes, thank you. So similarly, now we should know the parameters. The major parameters are the through variable as that across the variable. See, suppose if you take electrical or mechanical, so in this case, electrical is the if you want to calculate the how much power of the electrical energy in the sense, in that case you should multiply voltage and then current. So which means that across variable and across variable is multiplied by the through variable. So if you multiply this two variable, then you can calculate the total electrical power. Similarly, in the mechanical systems. So again here the through variable, if you multiply the through variable with across variable, then you can get a mechanical power, right? So what is the name of through variable in mechanical domain? So can you please comment? So what is the through variable in mechanical domain? So what is the through variable in mechanical domain? Can you please comment? What is the through variable in mechanical domain? Yeah, I'm waiting for your comment, participants. So, what is the true variable in mechanical domain? So, the true and then across variable in the mechanical domain is force. It's a torque actually, right? So, the torque as well as that velocity of the particular part. So, here the mechanical power is multiplied by the mechanical power is multiplied by velocity of the velocity of the part and multiplied by the torque. So if you multiply that, so that is that mechanical power P is equal to T into omega. So the omega will be a angular frequency or angular velocity, right? So like that, you have to understand the concepts. So similarly, what is the true variable in electrical domain? So what is a true variable in electrical domain? So what is a true variable in electrical domain? Yeah, what is the true variable in electrical domain? So true variable is the current in electrical domain. Similarly, across variable is the voltage. Right. So like that, if you know the basic concept, then you can easily understand the Simscape fundamentals. So again, you can develop your entire multi domain physical systems. So let us take, yeah, let us take a DC motor. See here in the DC motor, the electrical part will be there as well as the mechanical part will be there, because actually in the electrical part we will apply a voltage to the system, and whenever you are applying the voltage, since it's a motor is going to convert electrical energy into mechanical energy, so we should know based on the applied voltage and then current draw by the motor. So from this, we should know what is the velocity of the angular velocity, and similarly the torque, how much load can handle the motor, right? So these two variable we should know. So because this two variable only we are going to utilize in our electric vehicle systems, right? So in that case, we should know the basic concepts, how we can feed the two variable from the electrical circuit, and similarly how we are extracting this two variable from the mechanical systems. So now for that one, first you should understand the concept. So if you take any system, the energy flow will be a multiplication factor of across variable as well as the true variable. In the electrical domain, the power is the the power you have to calculate by voltage as well as the current, right? So the voltage unit is V, and then current unit is amps. And similarly, in the electrical system, if you take a this is a source model, and this is the load model, right? See here, if you take a MATLAB, I'm going to just open the MATLAB, create a new block, and just open the library browser. So just go to Simscape, just a Simscape electrical, and sources. Yeah, so just to take a voltage source, see here the voltage source will be here. So just to take it, and similarly the component, resistance. So you can take it the basic resistance like integrated circuit. So you may get a resistance. Yes, electromechanical sensors. Actually, I forget the yeah. See here, here you can take a passive, that is that resistor. See, if you take this two model, just to take a DC volt, I mean voltage sensor, voltage source. Just to take voltage source and take a resistance, so that from that we must know what is the true variable and then what is the cross variable. So we have a plenty of methods to measure these two variables, right? So just to take resistor. So since it's a Simscape block, we should integrate, we should add the we should connect library block called a solver. So just to take electrical reference, just to take electrical reference and take a current sensor. Just to take a current sensor, not a current measurement, just to take a current sensor. Yeah, I will remove my screen so that you can easily understand. Yeah, see, this is the true variable. You have to measure, you have to connect, and similarly we have to measure the across variable, right? So across variable, take voltage sensor. Just flip it. Yeah. So see here, this sensor is used to measure the voltage available across these 2 points. Similarly, current, how much current flows to the load. So this two variable you can take it. So just to take a solver configuration. So this solver configuration is going to give you the header file for the Simscape libraries, and take a PS2 PS2 Simulink converter to verify the data, and yes, and now take a display model. Take a display model so that we can measure the output voltages, output parameter. So now this is very basic electrical system. Similarly, we have to develop a mechanical systems, right? Just to save the simulation. Yes, just save the simulation. So just to run the simulation, just to run this, yeah. So we have not applied the voltages. So just to take a voltage. So this is the common source for both the AC system as well as the DC systems. So just to take apply 12 voltage DC. So remaining, since it's a DC supply, then you can avoid the further values. Yeah. See here, it's a 12 voltage and then 1 ampere. So the entire voltage is, I mean, the load will be draw the 12 amps, right? So this is that value. Similarly, if you vary the values, like a 12 voltage divided by 5 ampere. So in that case, if you run, then you may get, if you apply the resistance value, then you can run you can get a 5 ampere here. All right. So this is the true variable, and similarly across variable. Similarly, see, actually the Simscape library will work, will solve the entire equation based on the some basic equations. So for the electrical systems, it's working under the Kirchhoff voltage law and then Kirchhoff current law. So do you aware of the Kirchhoff voltage law and then Kirchhoff current law? So that is a very basics basics of electrical systems. So do you aware of the Kirchhoff voltage law and then current law? So can you please comment what is Kirchhoff voltage law? Can you please comment what is Kirchhoff voltage law? Yes, great participants. Thank you. Exactly. So now we should develop the some logics also, right? So this is the voltage sensor and then current sensor. So similarly, in the mechanical domain, see here there are the two variables. One is called angular velocity. So this is the omega, and then torque. So the mechanical power is the multiplication factor of torque with angular velocity. So to how you can measure the torque in the Simscape library, you have a measurement device called the ideal torque sensor, and similarly to measure the angular velocity you have an ideal rotational motion sensor. So now you need a basic system to change the to sense the these variables. So how you can sense the variable? First you should develop a basic mechanical system. So from that one you can integrate these two things, right? Yes, thank you participants. Thanks for your valuable comment. Attendance form will be provided, so don't rush up participants. Please be patient. Attendance form will be provided. Just wait 1 or 2 minutes. So here we are going to use the same logic how we can integrate these things, right? Similarly, you have a variety of domains like electrical, hydraulic. Please take a note about these things. So in this one, you can take a exact value of the power. So how you can measure the power? So like this, you can. Like this you have to take a product of this across as well as the true variable, then finally you can calculate the total power which is transferred or which is available on the particular systems. So now so the entire Simscape environment is working under the Kirchhoff voltage law as well as similarly Kirchhoff current law. So I have some basic two demonstrations. So just to take this one. Yeah, see here this is the Kirchhoff voltage law. So in this one in the particular loop the summation of all the voltages will be 0, right? So is it clear? Summation of all the voltages will be 0, right? Similarly, yeah, so this is the Kirchhoff voltage law. See here, this is the input source. So this voltage we have applied 50 voltages, and two resistance is connected, and yeah, this is the one, and then second two. See across this each and every the summation of this voltage across this resistor and then R2 resistor is equal to the total available of the voltage. So if you start the loop from 0 at this point, then if you come across like this, then the voltage available, the entire loop will be the 0. So if you calculate the entire thing actually, right? Similarly in the current law, Kirchhoff current law. So if you take any one of the node, so this node, the incoming current is equal to outgoing current, right? So this is the very basic principle. So this logic is common for all the systems. So from this you have to apply all these things actually. All right. So I have a Yeah, so this is a Kirchhoff current law. See, if you sum this one, just apply say whatever you have the sources. So if you apply this one, then the incoming current, so 5 plus 10, so 15. Similarly, this is the outgoing current. So incoming current is equal to outgoing current. Or else, if you take any particular node, all the currents will be zero, while if it is in the incoming current. Right, so like this you can calculate the Kirchhoff voltage law and then current law. So the idea is we are not going to ensure, verify the KVL or KCL. So the concept is the entire Simulink Simscape is going to work under this principle. If the concept is working for electrical domain, the same law concept will be applicable for the remaining domains, right? No, this large Madhavi Kumari. So this is the common logic for everyone. So in the sim power system also it will work based on this one only. Since actually why we are taking this here, Simscape is going to be almost near to the hardware systems. So that's why we are going to discuss about this. So now we have to take a rotational mechanical system. So in this mechanical system, so first take any one of the source, right? And so from this source just apply a value. So from here how this source is going to act, like so let us take this is a mechanical rotational source. Yeah, see here let us take ideal torque source. See for that one just to go to the library browser, and create a system. Yeah, so take open the library browser. So earlier it was the electrical system, so now we are going to develop a mechanical system. So just open the library browser and see here foundations mechanical sources. See here that just to take ideal torque, so ideal torque source as well as that ideal angular velocity source. So both the thing you can take it. So let us take ideal torque source. Just take this model. Just to take this model. Just rotate it, and so now just to take a rotational sensor, rotational motion sensor. Okay, so first we are going to measure the rotational motion sensor. So for that one, again there is a system sensor. See here ideal rotational motion sensor as well as the rotational torque sensor. So the both the thing we can use it. So let us check one by one. So take a ideal rotational motion sensor, right, and connect this one into this one, and so now we have to connect electrical reference model. So the reference model is nothing but mechanical rotational reference. So see here again open the library browser and mechanisms. Yeah, see here mechanical rotational reference. So take this one. Yes, and now let us take, so this is the directly we can sense the output value. So this is the sensor. So for that one also we have to feed the reference value. So just to use this reference, take this reference and then connect sensor, and so now we have to apply a value, right? So for that one, since it's a Simscape component, so we have to take a PS to Simulink to PS converter. So Simulink to PS converter. Yeah. So now we can feed the source. So since it's a control signals, let us take a control signals. So we can apply control signal via this block. So the constant block. So you can just apply this one. So you can take it. And now so this is the angular velocity, and then this is the angular position, and then this is the speed of the motor or rotational input speed. So just again take a PS2 Simulink converter, PS2 Simulink converter, connect to the scope, connect to the scope. Yeah. So no need to worry about this sensor. Since it's a sensor, so we can take it. And again, we have to connect a solver, right? So just to take a solver configuration. Otherwise, the system simulation will not work. So just to take a solver configuration. Yes. So like a solver configuration. So now just we are going to measure the basic mechanical systems. So in this one, so just we are applying the source to the torques, ideal torque source. So if you apply the value, then you can the system will respond, right? So let us run the simulation. Okay, so we have to connect at the inertia also, so that system will get fulfilled. So just type here, take a inertia block. Take an inertia block and take a rotational damper. Yes. Yes. So now let us try to run this one. Similarly, we have to add the additional variables called the speed increaser, see speed decreaser. See here, see we have just apply a torque source, so it has generated. Then the system is going to run, and it's generated the radian per second velocity. That is the angular velocity of the systems, right? So like this, we can sense the particular value that is called omega. Yes, we can measure. So like that, we have to measure the torque also. So in that case, so first you have to develop a entire mechanical systems, and you can integrate to the if you develop the DC motor, then you can measure the motor's speed as well as the motor's torque. So in that case, you can get the primary side will be the voltage and then current, that is across and through variable. Similarly, the secondary, that is in the mechanical systems, angular velocity and then torque of the particular motor. So if you combine these two things, then you can get complete electromechanical systems. So is it clear? So now let us add the gearbox model, how the speed is changed. So let us take a gearbox. Just to take a simple gearbox. And we can adjust this speed also. This is not one. Just to take simple gear. Yeah, see here, this just to take this model. And so again, just to take a additional, so what is the input of the speed as well as similarly what is the output of the speed. So both the thing we can measure it, and take this one. Yes. Just to connect C model. Similarly, just to take this one. So we can take input speed as well as that output speed of the gear systems. So now you can change the polarity of the systems also. So here you can double the values also. So since it's a, let us take one, sorry, let us take a 2. Just save this one. So let us try to get the results. Similarly, in this example, so just we take a torque source and then we are measuring the angular velocity. Similarly, the gearbox is going to change the speed of the system, and after that, this speed, how the speed has been changed. So both the parameter we can get verified. Just run the simulation. Yes. See here, initial value, that is that. So let us take separate the graph so that we can easily understand what is the input and then what is the output. Yeah. See here, the input is that about 2500 radian per second, and output is that it's half of the value. So now it is divided. Right, so it's whatever it is we are giving, so this value is divided by 2. Similarly, if you increase that 3, then the value will be divided by 3 or 4 or whatever you want. So like that you can vary. So the idea is, in this mechanical system, so we can measure the angular velocity like this, right? And now let us take the exact electromechanical systems. So in the electromechanical systems, generally the DC motor will have two systems. One is called primary and another one is called the secondary. So here we are going to apply a voltage input, and then we are going to take it as a omega is the one of the output, and another output is the torque, right? So now if you take a DC motor, connected by connect voltage, in that case we can get a motor's value, right? So the motor speed we can measure it, right? So this is the input speed. Similarly, you can apply a gearbox system to change the speed, because in the electric vehicle system, generally the gearbox is not mandatory, since it's a motor can run at any speed, and then you have a wide range of speed control mechanisms, so you no need to worry about the speed speed variations. But still it's a vehicle system. You must know the gearbox models which is developed, which is involved in the electric vehicle systems. So that's why I have added this gearbox system to this one. But as per the electric vehicles, the gearbox is not mandatory. So to increase your system flexibility, then you can add it. So already I have modeled this one. I will share you the example. Just take this one. Yeah. See here, the input take a DC motor. So the DC motor parameters are like this. So 750 RPM, 500 RPM, no load speed, and then 2 kilowatt, 100 voltage power. And as the armature inductance, you just choose whatever the minimum value. So I took a 5 millihenry. Right, so you can choose the rated power, rated speed, and then no load speed type. So other things no need to change anything. So still, if you developed all the formula, then you can apply here. But if you don't know the all the information, so you can feed this information. This is enough to get it. So now we are going to apply a DC voltage like 100 volt DC, and other things after the DC. So this is the motor shaft, right? So initially we are going to measure the motor speed. So what is the input speed? And similarly, we have not applied any load to the system. So simply we are just connect the gearbox. So this gearbox will divide the input by 2. Right, so this will divide the input by 2, and again we are measuring the output voltage. Sorry, output speed. Similarly, you can add the torque sensor to sense the value or value of the motor. So torque value, all right. So just run this one. Yeah, Mr. Abhishek, the value. The YouTube classes will be available only for the 3 days, not all the things. So you have to rewatch the classes within 3 days only. Within 3 days. So if you need more, then you have to enroll into the uh, internship. Yeah. See here, the red color is the input speed about 90 I mean 80 RPM. So radian per second, and similarly this is the 40 radian per second. So it's almost half of the value we have we are getting, right? See here. So in this domain, so just this is a very basics of the how we are measuring the motor speed in the mechanical systems. Similarly, we are going to include the torque parameters with this system, and gearbox, and then changes of the gearbox. So everything we will include in one by one, with this example, right? So I recommend you everyone. So please redraw the experiment and practice it. So just to try to get the same result first. Right, so just to take a same result, and then you can get into this one. So in the rotational motion sensor, A is the just a position, right? So omega W is nothing but the W is that is the omega, so that is angular speed. Yes, yes, Shilpa, please engage with the 30-day class, then you will get to know about all the things. So without this basic mechanism of the Simulink, then you cannot get it actually. Yes. So I recommend you everyone. So please redraw this experiment and take a same output so that you can follow my next classes. So else it will be some difficult. So just to take this screenshot and then identify the component names in the Simscape block sets and practice this one. Yes, now you can ask your questions. Yeah, speed control and all we will include in the next experiment. Forthcoming experiments. GS GADS f of x is the header file for the Simulink Simscape header library files. Yes. Thank you. If you have any more questions, you please WhatsApp me and comment in the comment box. I will give you the answers. Thank you. Thank you once again.